Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and the question belongs to paper 9709/41 for the session May June 24. Let's read question number 5. A straight slope of length 60 meter is inclined at an angle of 12 degree to the horizontal. A bobsled starts at the top of the slope with a speed of 5 meters per second. The bobsled slides directly down the slope. Question number A says it is given that there is no resistance to the bobsled's motion. Find its speed when it reaches the bottom of the slope. So first of all, let me sketch it up. Before sketching the system, there should be one more important part of your solution, and that is to pick up the concept which is more appropriate for solving the question very shortly and easily. So let's see which concept is the most suitable and appropriate for solving this question. Look at this. Here you may think in a different from different viewpoints, but I think it's very easy and very shortcut to apply the work energy equation, because work energy equation produces the final as well as initial velocities, and they have asked us to find the final velocity. So for final velocity, this is the easy way to apply the work energy equation. So for work energy equation, we will have to sketch this figure. We require, what are the components we require? We require height, initial velocity, and the rest of the information which are available. So let me sketch the figure. Suppose this is the plane which is inclined at an what is the angle? Angle is 12 degree. Okay, 12 degree, and the length of the plane is 60 meter. 60 meter, and we require height. Well, this is our height. So height is equal to, how can we find height? Height is nothing but 60. You assuming this as a right angle triangle. Hypotenuse is, this is the plane, and we can write 60. H is equal to 60 sine 12 degrees. 60 sine 12 degrees is our height. Now let's start applying our concept. We have already decided we are going to apply the concept of work energy equation. So what is the work energy equation? Work energy equation is nothing but work done by driving force minus work done by resistance force is equal to change in GPE. Change in GPE means change in gravitational potential energy plus change in kinetic energy. Well, then, now what is our driving force in this case? Actually, it is a very important part of the solution to be remembered. Is work energy equation calculates only any external force acting on the system. Remember, there is no external force acting on this bobsled. Bobsled itself, look at this, it is written bobsled slides directly down the slope. So it slides itself. There is no external force acting on this. If there is no external force acting on the object, then there will be no driving force in work energy equation. Remember, in all concepts we don't think so, but this is exceptional. In work energy equation, only the external force will be calculable, as there is no other external driving force. That's why driving force is zero. As driving force is zero, so work done by driving force is also zero. Now resistance force. About resistance force, it is written that there is no resistance to the bobsled's motion. So there is no resistance also, that means there is no work done by the resistance force, which is 0. Now change in GPE, change in GPE is actually m, the formula of mgh. Okay, mgh plus change in kinetic energy is, the formula is half mv squared. Okay, so as left side is 0, let it be written. Then m, mass of the bobsled, it has been ignored. Actually nowhere mass of the bobsled has been given, that's why it is going to be ignored from both quantities. Now g, acceleration due to gravity is 10, we know. And h, now we have already found h. Remember, in change in GPE, both the final and initial heights are required. So initial height, suppose if this is initial height, so this will be the final height. So initial height is more. Look, initial height is more, but we usually subtract initial height from final height. As final height is 0, initial height will be negative. That's why we are going to use negative symbol, negative 10. And h is what? How much is our height? It is 10 into 60 sine 12 degrees. Sine 12 degree. Well, plus half. Same goes here also. We have already ignored m. And v square. Which v square is this? Actually here also both the initial velocity as well as final velocity are to be calculated. Final velocity should be written first always. Final velocity is v square, and initial velocity has already been given. Then it started sliding with the speed of 5 meter per second. So 5 v square. What have we learned from this step? Always the final velocity should be written first, as well as final height should also be written first. So final height was 0, and initial height, actually this is the difference between the final and initial height. If we subtract the initial height from final height, it will be negative, because initial height was more, since the bobsled was sliding downward. Well, let me try to write just below this. After that we will get, or 0 is equal to 600, negative 600 sine 12 degree, plus it is v square over 2 minus 5 square means 25 over 2. 25 over 2. Let us isolate v square, because we require v square over 2 is equal to, that is, as it is transposing its position to the other side. So it is 600 sine 12 sine 12 degree plus 25 over 2 means 12.5. Well, and if we transpose this 2 to the other side, it is going to be, so v is equal, we can simply write this, v is equal to square root over, if 2 multiplies this, it is going to be 1200 sine 12 plus, if 2 multiplies 12.5, it is 25. Hence our velocity is going to be, velocity will be definitely positive, because it was in increasing rate. Hence our velocity is going to be, let me calculate this, square root over 1200 sine 12 plus 25 under square root, it shows 16.56. That means if we round it up to three significant figures, it is going to be 16.6 meter per second. So this is what the final velocity of the bobsled is. So what have we understood here? First of all, we will have to pick up the concept, and here we have chosen the concept of work energy equation. And in work energy equation, remember the two basic points. One is for driving force, only externally, if any force acts externally on this system, that will be calculated. Weight is not calculated as driving force. Now there may arise one more question, that why don't we in other concepts, in the concepts of motion law of Newton, we use weight as the driving force? Why is it not here? Actually, weight has been dissolved by change in potential energy. Change in potential energy. Look at this here. We have already dissolved the weight through change in GPE. And the other point is height. In case of height and velocity, always the final height and final velocity should be written first. So final velocity here, if we talk about height, final height was 0, initial height was 60 sine, not 60 sine, 60 into g, 10 into 60 sine 12. Okay, height was 60 sine 12 degree. This is our h. Okay, that's why we have used here negative symbol for writing h, and g was acceleration due to gravity is 10. So in short, we must not forget that final velocity should be written first in case of work energy equation, and secondly final height should be written. That means this is the difference between the final and initial velocities, as well as difference between the final and initial heights. That's why we use final height first, then we subtract the initial height. So is for velocity. And the other major point for work energy equation is no, that means only the external force. If external force causes the system or the object moving downward or upward, then that external force is calculated as driving force. Otherwise weight is not calculated as driving force. I think you have understood this. Let's move on to the immediate next question. The next question says, next question is on the next page, page number 9. Let us read the question number 9. B. It is given instead that the coefficient of friction between the bobsled and the slope is 0.03. Find the time that it takes for the bobsled to reach the bottom of the slope. As I always tell, in case of solution to any problem of mechanics, the major part of your success is actually choosing or selecting the correct concept. If you fail to pick up the correct concept, then it will cause wastage of your moment, and consequently you won't be able to answer all the questions smoothly. So here in the immediate previous question, we have applied work energy equation because we explained that that was the shortest as well as simplest method to be applied for such solution. But in this case, we are not going to apply the work energy equation, because look here, we will have to find out time, find the time. So time stands for T, and if we want to find out T from work energy equation, then we require power, because driving force, work done by driving force is equal to P into T, power into time. As power is missing, so we cannot apply the work energy equation in such solution. So what is the next option for us? The remaining option is we will have to apply Shubert formula. Shubert formula, in Shubert formula always acceleration is necessary. Without obtaining acceleration, we cannot apply Shubert formula. So we will have to find acceleration, that is final. For finding acceleration, there is only one concept remaining for us, and that is the concept of the motion law of Newton. So let's start with the concept of the motion law of Newton. And before that, let me sketch the figure. I mean, the system should be drawn. If I draw like this, the bobsled is sliding down over here. Let me erase this unnecessary part so that it looks a little convenient. Well, then here is bobsled. Let me draw once again. So this is the inclined plane, this is the plane, and this is the horizontal. And suppose here is the bobsled. Okay, so but first of all we will draw weight. This is weight. Weight always acts vertically downward, and then this is normal force. Okay, this is our normal force, and if we join up, then it is going to be like this. Okay, now it is a right angle triangle. In right angle triangle, you know this is 90 degree, and our angle is 12 degree. Angle is 12 degree. Well, then this is weight as I have told, and this is normal reaction. Okay, as they have mentioned, the plane is now rough, it's no more smooth, there is frictional force. So we will have to find first the frictional force. We know that frictional, I mean normal reaction is equal to R plus upward force. There is no upward force acting on the bobsled. Mine equal to downward force. Downward force is this one, as we have already decided this is the normal reaction line. So this is our downward force. So downward force is what? We know that it is, so downward force is actually this one. Okay, this one, which is mg cos theta. Mg cos, what is the angle? It is 12 degree. So hence our normal reaction is R equal to mg cos 12 degree. Well, then we will apply our concept. It is sliding down. So driving force, the concept we have already chosen is the concept of the motion law of Newton. Driving force minus resistance force is equal to mass into acceleration. Well, so driving force is what? It is nothing but the weight. Weight is, look at this weight is actually causing it moving downward. So if we want to find this weight, how can we find this horizontal? I mean this, according to this triangle, it is actually vertical line. Look at this. So vertical component of weight is what? It is mg sine 12 degree. Look, it is no more horizontal, actually this is vertical line in term of this drawn triangle. That's why, though this is we are finding the horizontal component in term of triangle, this is now vertical component. So vertical component is always mg sine 12. That means weight which causes sliding down is actually mg, component of weight will be mg sine theta minus resistance force. So resistance force is, we know if the plane is, surface is frictional or rough, then the formula is mu r. Mu r, we have already found our r. Look at this, r is mg cos 12. Mg cos 12, m into mu into mg cos 12 degree equal to mass into acceleration, ma. M A. Well, then let us simplify this. M can be ignored from everywhere because this is common in every side. So sine 12, g sine 12, g is actually 10. That means acceleration due to gravity into sine 12 degree minus mu. Mu is the frictional coefficient. They have given us that the frictional coefficient is 0.03. 0.03. So 0.03 into g, acceleration due to gravity is 10 cos 12 degree. Cos 12 degree equal to acceleration. We need acceleration actually, as I have explained initially. We require, for applying Shubert formula for getting time, acceleration is essential. So first of all we will have to find acceleration. Let us see, acceleration is equal to, hence our acceleration is equal to, let me calculate this, 10 sine 12 degree minus 0.03 into 10 cos 12 is equal to 1.79, 1.78. Let me write few more digit. 7 8, then 5 6, so let it be 6. 1.786 meter per second square is the acceleration. Now we can easily apply the Shubert formula. So what is our Shubert formula? S is equal to S equal to S equal to ut plus half a t square. Okay, so S is actually displacement, means length of the plane. Length of the plane is given in the previous question, it was 60. In the previous question, page number 8, here the length of the, here it is written, look, the length of the slope was 60 meter, 60 meters. So we can apply this 60. So 60 equal to initial velocity. Initial velocity, we have not forgotten that it was 5. So 5t plus half of acceleration. Acceleration was 1.786, 1.786 t squared. Okay, now if we simplify this, it is going to be, let everything be written on the same side, 1.786 t square, t squared, t squared, let me write squared, over 2 plus 5t minus 60 is equal to 0. Let me write just beside this, as I don't have space over there. Let me write over here. It is 1 or 1.7856, 1.786, sorry, 1.786 over 2 plus 5t plus 5t plus 5t minus 60 is equal to 0. So if we dissolve these two, we will get 1.786 t square, sorry, it is t square, t square, t square plus 10t minus 120. Minus 120 is equal to 0. Hence, applying quadratic equation, t is equal to, applying quadratic formula, we will get negative b plus b square minus 4ac, 10 square, and minus minus plus 4a is 1.786 and c is 120. Well, now you may ask a question. In quadratic formula, actually 2 into 1.786, you may ask a question. Quadratic formula is applied for both positive and negative symbol, but look at this, already our first quantity is already negative, so it cannot be negative at all, because t must be greater than or equal to 0. Hence our t is going to be, let me calculate, negative 10 plus square root over 10 square plus 4 into 1.786 into 120 over 2 into 1.786 and bracket. So it's t equal to 5.862. If we round it up to three significant figures, it is 5.86, 5.86 second. That is what our required time for the bobsled to reach the bottom or reach the ground. So thank you all for watching the video. Let's talk with you in the next video, inshallah.